Welcome back, Algebra 2.1 students. This is another lesson in our sequences week. So this is geometric sequences. We're going to go through the bell work. That's going to correspond to the homework quiz for arithmetic sequences. That's what we did yesterday. We're going to go through the objective, the essential question, see what geometric sequences are all about. We're going to go through a couple of examples. How do they work? How can I work them? What's the difference between arithmetic and geometric sequence? And then, of course, we're going to go through the summary and the homework. So let's get started. These are the two questions I have for you on the bell work. This probably are going to be on the homework quiz. When I say probably, I mean very, very likely. So FYI. Let's go through the first one, and then we'll make some room for this second one. If you need to pause the video at any time just so that you can copy them down, by all means do so. Let's get to it. So this first one says, write the first six terms of the arithmetic sequence shown below. We have a sub n equals a sub n minus 1 minus 17. And then comma, a sub 1 equals 34. So we just want to write the first six terms. How do I write the first six terms? Well, they give us a couple of things. First of all, they give us a sub 1. Remember, this is what we call my first term in the sequence. The second thing they give us is actually this whole formula. This formula right here, I'm going to cloud this. This whole formula is what we call, if you remember from yesterday, our recursive formula. Recursive formula. Okay? And in our recursive formula, there's one thing that we actually need to take out of that formula, and it is literally that number. Why? Because this number right here, this negative 17, is actually our common difference. So I'm going to write that down and say that's my common difference, negative 17. So a sub 1 equals 34, d equals negative 17. We have our two variables that we need in order to complete the first six terms. So if this is our first term, a sub 1 equals 34, what is my second term? Well, I just need to take the first term, the preceding term, and then tag on my common difference, which in this case is minus 17 or negative 17. So what does that equal? When I subtract that, that actually just gives me 17 back. So a sub 2 is simply 17. Now what is a sub 3? A sub 3, we're going to take our preceding term, 17, and then minus our common difference again, 17. And this is a nice and simple one. It's just 0. Ha! Isn't that great? It's awesome. Yes, it's fantastic. A sub 4. What is a sub 4? A sub 4, I take 0, my preceding term, and then minus 17. And this, of course, is negative 17. So this is a very simple problem. A sub 5, I take negative 17, my preceding term, and then minus 17 again, because that's my common difference, and I actually get negative 34. After I get negative 34, I'm going to go to my final term that I want to find. That's going to be a sub 6, so negative 34 minus 17, my common difference. What is this? Negative 51. So what is Math Excel going to be asking you to write down? Often, and pay very close attention, often they will actually ask for a sub 1 again. Yes, they will probably ask for a sub 1 again, which is really crazy because they just gave it to you. But yes, oftentimes they will ask you for a sub 1. And if you accidentally put a sub 2 in spot of a sub 1, don't worry. You can review your homework quiz and then ask for partial credit if you need to. Okay, just like what I've talked about last week. And then they'll also need this, of course, a sub 2, 17, a sub 3 is 0, this is a sub 4, a sub 5, and of course they need the last term, a sub 6 equals negative 51. So what does this sequence actually look like? 34, comma, 17, 0, negative 17, negative 34, and then negative 51. Can this go on forever? Of course it does, but it only stops right here at the sixth term. 1, 2, 3, 4, 5, 6. Awesome. All right. Let's go to the next one. I'm going to erase this, and we'll get to this huge one here. All right. I did go through this question or similar question on the last video for arithmetic sequences towards the end. I think it was like the last question, but I'm going to go through it again just so that we understand what it's about, how I can go around this, and so I can understand the math. Because again, you may see this on the homework quiz. Let's get to it. The first thing you see is company A. So company A pays its employees $24,500 yearly with raises of $1,700 per year. So the first thing I notice is this, 24,500 yearly. I actually start out, if I got hired there, I start out with that much. So this is 24,500. Okay, and then my common difference, what it increases every single year is actually this $1,700 per year. Okay? And then company B, I'll write this down on the other side. Company B pays its employees $28,000 yearly with $700 per year of raises. So similarly, A sub 1, my first term, when I first get hired, the first year that I'm going to get paid, I'm going to get $28,000. My common difference, how it increases every single year at a constant amount, that is going to be $700. Awesome. So now, before we get started, let's go here. This is my formula, my explicit formula that we discovered and we worked through yesterday. A sub n equals a sub 1 plus parentheses n minus 1 times my common difference. This is my formula, so I'm going to follow that formula. Let's get to it. So I'm going to go to a sub 10. Now, why a sub 10? Why is my n here? I'm actually going to put this in red. Why is my n equal 10? Okay, because we want to know in both years or both companies, after 10 years, how much will you make? So in company A, how much will you make after 10 years? In company B, how much will you make after 10 years? So that means my n is going to be 10, and that's going to remain the same for both problems. So a sub 10 equals a sub 1, which we said was 24,500 plus, and then this is going to be 10 because that's my n, right? Minus 1, and then times my common difference of 1,700. Now, watch what I'm about to do here. I'm going to actually put this whole thing in to Desmos.com. I want you guys to get familiar with Desmos. If you're not familiar with Desmos, that's a shame because you ought to be. Okay, I'm actually going to put this whole thing into Desmos.com. Whoops. So let's get started. 24,500 plus 10 minus 1 times 1,700. Okay, so I'm going to do that. 24,500 plus parentheses 10 minus 1. Okay, and then I'm just going to add parentheses here. We had $1,700, right? Notice how they actually give me the whole problem here. Okay, this is company A, and they give me the whole thing. So I can literally just type that in exactly how I see in Desmos, and it calculates it for you. So what's my answer? 39,800. I'm going to go over here, and I'm going to write 39,800. This is my answer. I'm going to include the dollar sign because technically we're talking about money. Great. Now let's go to the next one just to see how we can compare them because I don't know if it's any less or more until I actually solve this. So my a sub 10 equals my a sub 1. In this case, it's 28,000. And then plus, again, 10 minus 1. And then my new, I'm going to add parentheses here, my new raise, my common difference is $700. Not $1,700, $700. So now let's go back to Desmos and change this stuff. So 28,000 plus 10 minus 1 parentheses times my common difference of 700. I'm just going to do a whole new one. Let's do 28,000 plus, I have 10 minus 1, and then times 700. Now notice I'm making considerably less. So considerably less. Look at that, 34,300. So if I go back, I actually make 34,300. Was it 300? Yeah, $300. This is how much I make in company B. Now, Math Excel is going to ask you for both. It's going to ask you for company A and it's going to ask you for company B. Now, our last thing that's going to ask, if you like steps, this is step 1, this is step 2, and then this is step 3. Step 3 is going to ask how much more will this company be paid? So obviously, this is the one that pays the most. So you'll select, okay, company A pays the most, pays more. And now it's going to ask you how much more, okay? So all we have to do is a simple subtraction problem. I take the 39,800 minus the 34,300, and then I subtract them. What can I do here? I can literally do the exact same thing on Desmos. Now, the cool thing is this, guys. I can actually label this. Watch this. You ready? I can actually label this as A equals. And I can actually label this as B equals. And then I can go down here and literally just say A minus B. And then it will give me the subtraction. So it literally takes the 39,800, what I got for A, minus the 34,300, what I got for B. It takes that, subtracts them because that's what I did here, and then it actually gives me what it is, which in this case is 5,500. So my answer is $5,500 more. $5,500 more. Smiley face, unicorn. It's kind of sad. He looks sad. Sorry. So that is the full problem. Great. So please pause the video, see if you can get all this down. I'm going to erase. And now you will be starting on your homework quiz. So 5 questions, as always, 20 minutes, and of course, open notes. Please pause the video, get started on the homework quiz. Remember, if you have any partial credit, so right here, when finished, please review your answers, send any partial credit requests. When finished, review your answers, send any partial credit requests, only if necessary, to my email. Okay, so if you just maybe missed a number, if you forgot a comma, if you maybe put a parentheses when it wasn't there, or maybe put x equals and they just wanted the number there, anything like that, Math Excel will mark you completely wrong. But if you send me an email, I will go in and I will adjust it accordingly. Okay, so please make sure to do that. After you're done with the homework quiz, start your Cornell notes for today. We're going to go through geometric sequences. Awesome. Pause the video. All right, let's get started. So now it is essential question. What is it? What is a geometric sequence and how do we write formulas for them? You could even kind of add on to this. What's the difference between geometric and arithmetic sequences? We're going to actually discover that as well. Here are the objectives. You don't need to write the objectives down at all. Remember, you don't need to do that. But you do need to write down the essential question. What are the objectives? I can analyze sequences by identifying mathematical patterns that are found in the sequence using the formula, find the nth term. And then I can apply arithmetic and geometric sequences by defining, identifying, and applying my knowledge of sequences. So those are more like a little complicated. Really, you just need the essential question here. All right, we're ready to get started. Let's do it. So geometric sequences, what are they? Well, in order to kind of explain it, I want to show you this. This is kind of a wonderful array of beautiful looking things. Maybe you're thinking, oh, that's just a block, and then this looks like a snowflake. And it does look like a snowflake, because guess what? Geometric sequences are heavily related to what we call snowflakes. You can see what we call fractal patterns and chaotic patterns, but almost symmetrical patterns in sequential patterns in snowflakes, in precipitation during the winter. Of course, we don't get that here in Arizona, but I mean, we can hope, right? So think about this for me, guys. How many colored squares are in each of these pictures? So in the first one, how many colored squares, guys? It's very simple. You should all be saying, well, green, it's green, right? That definitely looks like just 1 because you're right. It is just 1. There's 1 colored square. Now, what about for this yellow here? What is that? Well, you can count 1, 2, 3, 4, 5. So there's five colored squares. Okay. Now, what about for the blue? Think about it. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And there's 5 groups of those 5. So what is it? Well, 5 times 5 gives me 25. Okay. Now, what about this one right here? Now, am I going to go in and actually like count every single thing? I could. Now watch this. There's 5 here and 5 here, 5 here, 5 here, 5 here, and it almost looks exactly identical to this. But what did we do from here to here to here? From each individual segment. What did we do? Well, we times by 5. So what is this? I mean, you can count them if you want, but really it's just times by 5. 25 times 5 is 125. Now let's look at the last one. Surely we won't actually count each individual one. If you want to try to like squint and try to do that, go for it. But really, again, it's just a pattern. Times 5, what's 125 times 5? It is 625. Now, what is going on? What's happening here? Again, we see a pattern arising, just like with arithmetic sequences, times 5, times 5, times 5. But what's the difference? The difference is we're multiplying instead of adding or subtracting. Okay, we're multiplying instead of adding and subtracting. So let's move on to our actual notes here. What is an arithmetic sequence? What is the pattern in each of these sequences? Then list the next 3 terms. Let's start going to town on this. So 4, 8, 16, 32, 64. What is the pattern? You should be saying times 2, times 2, times 2. So what are the next 3 terms? Well, 64 times 2 is 128. And then the next one is 256. The next one is 512. Okay, and of course this goes on forever. And what is the pattern here? Are my common difference 2? We're actually going to be calling it something different, but I'm going to hold off on that. And also, if you notice, if you're familiar with the 2048 game, when you swipe and everything, this is definitely the numbers for 2048. All right, what's the next one here? 6, 12, 24, 48, 96. What is it again? Again, it seems like it's times 2. Next 3 numbers, 96 times 2 gives me 192. Okay? 192 times 2 gives me 384. And then 384 times 2 gives me 768. Okay? And of course, it can go on forever. What is this number? Is it a ratio? Is it a common difference? We'll find out. And then here it is, of course, I'm going to go, whoopsie. I'm going to go a little bit faster because we kind of get the picture. Times 4 times 4 times 4. So 48 times 4 is actually 192. 192 times 4 is now 768. 768 times 4 is 3072, blah, blah, blah. Now, these are called geometric sequences because you get each succeeding term by multiplying a constant amount. Not by adding or subtracting. Multiplying a constant amount called the common ratio. So here, common ratio is 2. Here, common ratio is 4. And then here, for this last one, the common ratio is, again, 2. Okay? So I have a common ratio of 2. What's the difference? Arithmetic sequences have common differences. Geometric sequences have common ratios. So let's go to town. I'm going to erase, and let's get into something very similar, a recursive formula. Here is what it is. A sub n equals r times a sub n minus 1. Now, if an arithmetic sequence has a recursive formula, of course, a geometric sequence has a recursive formula. Will I ever use this, like verbatim, actually boom, 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 using the actual formula? No, because again, recursive just means working backwards or using the previous term. And we found the last video during arithmetic sequences that we really don't need the formula. All we really need to do is just use it intuitively by using the previous term. So I have this. I have the first 5 terms, geometric sequence whose first term is 162. So I'm going to write that down. A sub 1 equals 162. And then whose common ratio is actually 1/3. So I'm going to put R equals 1/3, not D, but R equals 1/3. How can I do this? All right, guys. Well, A sub 2 equals, I'm going to use the preceding term, 162, and I'm going to multiply that by my common ratio, which is 1/3. 162 times 1/3 should be 54. Now notice here, I'm going to erase this, but you don't have to write this down. Just notice, this is technically all over 1. And so really what we're doing is not just 162 times 1/3, but we're also technically doing 162 divided by 3, which is still, of course, 54. So we can do it either way. We can multiply by 1/3 or divide by 3. I'm mainly going to keep it with this way, okay, because we're multiplying with geometric sequences. We're multiplying the ratio, not dividing by a ratio, okay? So A sub 3, what is that? Taking the previous term, 54, I multiply it by 1/3. Of course, this is all over 1. What does this equal? This equals 18. Awesome. A sub 4, let's go to town. So this is 18, and then times 1/3. We multiply that. Technically, it's 18 all over 3, which 18 divided by 3 is 6. And then last, A sub 5. A sub 5, I'm going to take 6 times 1/3. This equals, of course, 2. So what's my sequence look like? I start with 162. My next term is 54. My next one, my third term is 18, then 6, and then 2, blah, 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 with a ratio of times 1/3, times 1/3, times 1/3, and then times 1/3 in between. Okay, common because it's the same thing all over the sequence, 1/3 because it's a ratio. You multiply. Great. Let's erase this. And let's use the recursive formula a little bit more now. So you're going to see something that looks like this. Nasty recursive formula. And of course, A sub 1. I always label my variables. So A sub 1 is right there. And then you start to see something that's like, what is this? It is a recursive formula, but then you see something like that. What is that? I need 2 things in order to do a geometric sequence. 2 things that I needed to do arithmetic sequence. I needed the ratio or the common difference, and I needed the first term. In this case, it's the ratio and the first term. We don't have a ratio, but we notice there is a number here, and that is going to be our ratio. Because if you go back, guys, remember, let me just go back here. If you go back, notice that you see this. Okay, this R is right there. Yes? R? So R is right there. I'm going to be using R, and I'm going to be putting that R in for that. So let's continue. Okay. Let's go through this one. I have the first 5 terms. I want to write the first 5 terms. I'm given this, the recursive formula for the geometric sequence in the first term. So A sub 1 equals -5. What is my common ratio? The common ratio is the same thing that I have here, this number. In this case, it is -6. Okay, so I like to write out my variables. Let's go to town on solving these questions. So this question right here, let's write it out. What's my second term? My second term here is going to be my first term, 9, times 4, my common ratio. 9 times 4, my common ratio, which in this case it is 36. Okay? a sub, I probably won't do all 5 terms for the sake of time, but a sub 3, if I do 36 times 4, what is that? 36 times 4, it's going to be 144. Now, if you have yet to pick up an awesome calculator, you probably should do that. Of course, you could use Desmos.com, but you can also use this. This is called the TI-36X Pro. Again, just a reminder, it was on the syllabus. You can pick it up at Walmart for like $10, $20, something like that. Yeah, I'm going to stop right there because, of course, we can just go through it, but I'm not going to, so keep multiplying it, you'll get it. Okay, let's do this one. So a sub 1 is -5, common ratio is -6. Let's go to town on this. So -5, a sub 2 equals -5, and then times -6. This one is going to be 30. And then let's do a sub 3 equals positive 30. Positive 30 times -6. What is that? That's -180. And we're going to stop again at a sub 3. But notice here, here's the difference. We started with a negative, then we went to a positive, and then we went to a negative again. So here it's just going to flip-flop back and forth. Just like arithmetic sequences, it would flip-flop back and forth. Or actually, no, arithmetic sequences didn't flip-flop, but here, because we're multiplying, when you multiply a negative times a negative times a negative, we start getting either positive or negative, depending on the sequence of my geometry here. So let's erase. We're going to start seeing that a little bit more actually in the next couple slides. So when we get to the explicit formula, we're going to see it most evidently, but let's go to town on what the formula is. It is very, very, very similar to the arithmetic explicit formula. In this case, it is a sub n equals a sub 1 times r to the power of n minus 1. Now, if you didn't know already, this actually looks very, very similar to exponential functions. Okay? Remember, we're doing sequences, guys, because sequences relate to functions. Tomorrow, our whole lesson is on functions. How do they work? What's the preliminaries of functions? What are the foundations? And then we're going to start to see that they are heavily related to sequences, okay? Because, FYI, sequences are functions, okay? This is an actual exponential function, but we're not going to get too deep into the woods with that. We're going to be given this problem. It's going to be telling us two different things. Number one, we'll put it in red here. Find the general term formula. So that's the first thing that I want to find. Find the general term formula, okay? To find the indicated term. So find the indicated term, which in this case, it is a sub 6. So this is my second step. First step, find the general term formula. Second step, find the actual indicated term using the general term formula. So first step, what is my general term formula? I'm going to actually write this out. We kind of did this at least through one or two examples in the last video with arithmetic sequences, if you remember. What's the general term formula? I'm actually going to list out my variables. Here are my variables here, already listed out. But I'm going to put them inside my formula except for n, because in this case, technically n equals 6, okay? So I'm going to be using a sub 1 and r into my formula, but I'm not going to use 6 as n until I get to step 2. So Math Excel will ask for what's the general term formula, and then you'll actually put this. So a sub n equals, my first term is 8 times 3, and then n minus 1. This is my general term formula, okay? So Math Excel will more than likely ask you first for the general term formula, and it's this. And then for the second, they're actually going to ask you find the explicit term. Again, pardon my awful handwriting. Explicit term. So that is when I'm going to plug in n equals 6. So notice now I'm going to do a sub 6. So this is 8 times 3 all to the power of 6, because that's my n, Just following it, following my formula, 6 minus 1. Now let's solve this by hand, and then I'm going to show you how to solve it on Desmos. Okay, so this is 8, and then 3, and then this should be 5. 6 minus 1 is 5. Now, this is what you don't do. You should not do 8 times 3, which is 24, and then times to the 5th power. Okay, do not do that. That's not the order of operations. What you need to do first is 3 to the 5th power. This is what you need to do first, 3 to the 5th power, which is a rather big number, and then, it's actually not that big of a number, and then times 8. So 3 to the 5th power is only 243, so it's moderately big. How about that? 243, and then I times by 8. If you want to put parentheses here, you can. What is that answer? That answer is 1944. 1,944. How can I use Desmos with this? It's actually very simple. I can use Desmos with this by just plugging in pretty much all of this. I don't even need to simplify that exponential right here, the 6 minus 1. So let's go to Desmos. I'm going to show you. Okay, so I have here, let's just call this A. Let's just call it A. All right, no big deal. Let's just call it G for geometric sequences. How about that? It doesn't really matter. Okay, I have 8, and then I have parentheses, and then 2 the power of 6 minus 1. Okay, whoops. This is another thing that Desmos will actually do right here, and you're like, that's wrong. You're an awful math teacher. I actually didn't do it wrong. Notice how this negative 1, is kind of off and not attached to the exponent. It's because in order to do that, you need to actually put parentheses around that negative 1 here. So let's go back and let's erase. And notice now I'm by the 6. My blinker, my cursor is blinking right by the 6. I'm actually going to go over here and put parentheses. Now, if you're asking, couldn't you just put that as 5 because 6 minus 1 is 5? Sure, yes, you could, but you'd be surprised that a lot of people don't think that way. A lot of students don't think that way. So now that I have parentheses here, of course, we get the same answer, 1944. So that is how you basically use Desmos or your calculator. You can use the TI-36X Pro. Again, $20 at Walmart. Everyone loves Walmart, right? Very simple calculator, and it's very, very, very easy to use. Even has a fraction button on it. Parentheses and everything, it's great. It's way better than the TI-84, which is really clunky and gross looking. Okay, let's erase. Let's move on. Finding a particular term. So if I want to find the 9th term, okay, the 9th term of the geometric sequence whose first term is this and whose common ratio is this, what do? It's actually very simple, guys. Again, I always like just rewriting my actual variables here. Even though they literally tell you and they give it to you in the problem, it's something that's weird for me. I just like rewriting it just so I know. Okay, this is my first step. My second step, after I rewrite my variables, also n equals 9, because right here, n equals 9, sorry. So after I rewrite my variables, I'm going to now solve the problem. But in order to solve the problem, I need to know my formula. A sub n equals a sub 1 times r to the n minus 1 power. This is my explicit term formula. Awesome. Now let's start to go to town. So a sub 9 equals, what's a sub 1? We have it right here in the problem. So this is 5,888. And then times my r, which is negative 1/2. And then to the n minus 1 power, so 9 minus 1. Okay. Let's go to Desmos and actually solve this, because this is actually a little bit more complicated and probably a little bit harder to do. And yes, you could use a basic calculator for it, but it's definitely easier just to plug it all into Desmos and then you get the answer. Okay, so let's go here. I don't want to do that. Awesome. Let's just call this H. Now, do you need to call it anything? No, I just like calling it other stuff. If you don't want to, if that confuses you, let's just leave it out. Okay, I'm just going to do that. All right, so this is 5,888 times -1, and then I can click the division here, click the division bar, just the backslash where your question mark is on your keyboard. And then I'm going to kind of scroll over and then do parentheses. This is all to the 9 minus 1 power. And here we're going to do 9 minus 1 right here, and we get this number. Or, if you don't believe me, we can just do 8, and we still get 23 as our answer. So let's go back here, and then this actually equals 28. So a sub 9 equals, not 28, 23. A sub 9 equals 23. Yay! Man, we're going to town. Let's go to more town, okay? Let's erase this junk. Let's go to here. This is something that you'll definitely see on Math Excel. It's going to ask you, number 1, find the general term formula, which we already kind of did. And then number 2, it's going to be like, find the 6th term. So let's list out over off to the side our variables. A sub 1. They give us a sequence here. What's our first term? What is the very first number? It is 5. So let's go over here. Let's do 5. What is my common ratio? I need that. My common ratio, let's see how these differ from boom, boom, boom. So 5 to 10 to 20, it should be very clear that that is times 2. 5 times 2 is 10. 10 times 2 is 20. And of course, we can continue it, but we don't need to. So what is my common ratio? 2. All right. My n, what is my n? What do they want us to find right here is 6. Okay, great. Now we go over here. They actually kind of will give you a template for your general term formula, and you just really need to plug in these two things. Now again, if you remember, my general explicit formula looks like this, times r to the n minus 1. So this is my actual formula. And what are the things that they actually want you to find? The things that are kind of in the box here, and it's the a sub 1 term and then the r term, which is super simple. You know why? Because technically they kind of already give it to you. You just need to do some deduction. So my first term is 5 and my r is 2. So what is my final answer? This. So literally Math Excel will give you a slight template just like what I did here, and then all you need to do is type in your first term and type in your common ratio. All right, your second step here, what is the 6th term? Now we have to actually calculate some things. So a sub 6 equals 5 times my r, which is 2, all to the power of 6, which is my n, minus 1. I'm going to plug this into Desmos and see what we get. So I have, so 5, that's my first term, times 2, my common ratio, all to the power of 6 minus, because 6 is my n term, 6 minus 1, so I get 160 here. So let's go back and let's type in 160. And then of course Math Excel will ask you to also type in 160. Now when it says simplify your answer, that's if you have like a fraction, or that's if you have like, basically a fraction and you need to simplify it as much as possible. That's what it means. But 160, of course, since it's a whole number, it's already simplified. Sweet. So let's go to town. I think we have just a couple more slides left, I believe. So let's erase this and go here. So this is an actual word problem. It's an application question that you'll see on Math Excel. You'll see on your homework, and you'll probably honestly see it as well for your homework quiz, FYI. So let's try to deduce, let's try to figure out what's happening here. So suppose you save $1 the first day of a month. $1, not too bad, about half the price of a Coke at the gas station. $4 the second day, $16 the third day, and so on. Okay, that is each day you save 4 times as much. I'm gonna actually circle that. 4 times as much as you did the day before. What will you put aside for savings on the 9th day of the month? So a couple things here. Of course, we're gonna list out our variables, right? So what is a sub 1? What does this sequence start with? It seems to me that starts with 1. 1, 4, 16, and then so on. So my a sub 1 is just $1 per day. Okay. What is my a sub 2? My a sub 2, they already tell us, is 4. Do we really need that right now? No, but I like to just list it out just so that we can kind of get a clear picture on what this sequence looks like. A sub 3, of course, is 16. That's the third day. So what does this sequence look like? 1, 4, 16. And then we want to know what is a sub 9. What is a sub 9? On this 9th day, how much am I saving? Okay. We also need a couple more variables. What is my R? Well, here it says 4 times as much. So you're saving 4 times as much as you did the day before. So you notice 1 times 4 is 4. 4 times 4 is 16. So that 4 there is going to be my common ratio right there. Okay? And then my n. What is my n? My n, we want to know the 9th day, so it is 9. And of course, we do want to know what is a sub 9. We're going to find that out. All right, so my formula, what is it? A sub n equals a sub 1 times r to the power of n minus 1. I'm going to keep writing it until we can kind of get the hang of writing it and so that we know it. So a sub 9 equals, my first term is 1. My common ratio is 4. And then I'm going to do 9 minus 1 here. Okay, we can actually simplify this out a lot. So this is actually 4 just to the 8th power, because 1 times anything is just 1, and then 9 minus 1 is just 8. So what is literally 4 to the 8th power? Once again, let's go to Desmos. So 4 to the 8th power, what is it? I do 4 and then 2 to the 8th power. What do I got? A huge freaking number. Okay, 6,536. I'm going to go over here, 6,536. 65,000, sorry. 65,536. 65,536. If you want to put a comma there, you can. Awesome. So that is a rather huge number. So what does this mean, guys? This means, this is dollars, by the way. On the 9th day, you are saving $65,000. $65,536 on the 9th day. Yeah, that is crazy. That's not, I don't even think that's possible, to be honest, unless you're like Bill Gates, okay? Let's erase. I hope that makes sense. Remember, this will probably be on the homework quiz for you. All right, so I think that's all I have. Here's the summary, the sequences review. We've learned a lot about arithmetic sequences. We've learned a lot about geometric. So first things first, what is the recursive formula for an arithmetic sequence? I have this. A sub n equals a sub n minus 1 plus d. Explicit formula, what is that? There's actually 2 of them. Remember, I usually use this one. I didn't really use that one, but you could use either way, either one if you wanted to. You could do it either way. For geometric, so geometric here, what's the recursive formula? It's actually this formula right here, r times a sub n minus 1. And then the explicit formula for geometric sequence, I have a sub n equals a sub 1 times r all to the power of n minus 1 here. Okay, so you don't have to necessarily write that down. I think it's beneficial for you to kind of like write it down and see, okay, this is arithmetic, this is geometric. It may be beneficial for you to do that, but you don't necessarily have to. Awesome. What did we learn? We learned a couple things. We found the common ratio for a geometric sequence, just like we did for an arithmetic sequence yesterday on the last video. We also learned how to write terms of a geometric sequence. We learned how to use the formula for the general term of a geometric sequence. Okay, we definitely did that. Okay, awesome. That is the summary. Let's go to town. What is your homework? Your homework is, of course, geometric sequences on Math Excel. Make sure you prepare adequately enough for the homework quiz. I notice a lot of you are just not doing the homework. Remember, I do take a homework participation grade on the homework. So if you don't do the Math Excel homework, you will get a 0 for the homework participation grade on Math Excel. Remember, if you do the homework at 100%, this geometric sequence at 100% before you take the homework quiz, by all means, you will get 2 extra credit points towards that homework quiz tomorrow, the geometric sequence homework quiz. If you have any other questions, please, please, please let me know. But until next time, I'm Mr. Carlson. This is C Squared Mathematics. Please like, subscribe, enjoy the video, enjoy the next video. If you have any questions, email me. I'll see you guys later.